Okay, so let's continue what we started on Wednesdays, because that's this is going to be necessary for lab 3. So we stopped at pointers. We went through some of the background about memory addressing, how the memory happens in the background. We understood that every single variable has an address, and C gives you the ability to really deal with that address by storing it and looking into it, printing it. We have done some exercising also on Wednesday on seeing, for example, the addresses of an array, how they are contiguous in memory, how they really show us that, well, ints are really 4 bytes. If you have something else, they will be spaced by that size. And this also handed us to what is the real meaning of the array name, which is the address of the first element of that array, or in other words, it's really a pointer to the first element of the array. Good. And then we already had the AND operator before, but now we know that this is basically read as the address of, right? So thinking about the AND operator, you read it the address of. For example, here I have AND n. So I have AND n. So the way I read this is I want to assign the pointer, n pointer, to the address of the variable n. Good. Then we stop the lecture on the concept of dereferencing or the indirection operator. And we said the way you can read this is the value of, right? So if I have an asterisk n pointer, it's really the opposite side of the AND operator. AND operator, you use it with a variable to get the address. Asterisk, use it with a pointer to get the value that it's pointing to, so to get the variable basic, right? So in other words, this line is completely equivalent to say n equal 20. Because I'm saying the value that n pointer is pointing to, assign 20 into it, right? Or the memory location that this is pointing to. So this is equivalent to n, because n pointer, we know it's pointing to n. So if we execute that line, we'll override the 8 by 20. Good. A very important point here is that both the n variable and the pointer that is pointing into it, both are on the same location. These are not two different memory locations. So this is why when we modified the value that n pointer is pointing to, n itself has been modified. So if you try to print n here, you will really get 20 as well. Good. So if I want also to print the value that a pointer pointing to, assume, for example, you don't know n, you can also do the same thing by the value of, right? So this operator, the indirection or dereferencing operator, it basically gives you the variable itself. Good. So again, if you are confused, think about the AND gives you the pointer and the asterisk gives you the variable that the pointer is pointing to. Are we good so far? Is there any question, please? Yeah, well, generally the answer is no, right? There are subtle differences when it comes to arrays, because, and we'll come into this later on, is we said that the array name is a pointer to the first element, but we also had a rule 2-3 lectures ago when we talked about arrays that you can never assign something to the array name. You cannot say A equal B, for example. But now we can in fact assign something to a pointer, right? So that means the array name is a pointer, but it's a special type of it. And the reason for this is the array name is a static pointer, a pointer that cannot be modified, right? So that's one subtle difference, is that if you want really to change a pointer, it has to be a dynamic pointer, which means something you defined yourself, right? And we will have more examples about this later on. But generally the answer is no, like both are completely equivalent. Maybe dealing with pointers is a little bit more complex. But it has its own use cases. Again, we will have a few examples later on. Good. But the last sentence here is the one that we want to emphasize. If you are modifying the dereferencing of n pointer, this is in fact means n itself has been modified, because they are the same thing. Good. Now, some examples of how I can use a pointer and how this reflects in memory. So let's just one step back here. So what I'm doing in these 5 lines, so first of all, I'm defining a pointer, and this is the first time we see that thing. What does that mean? So previously we said when you define or declare a variable, it should be a good programming practice to always initialize it to some value, right? And we said, well, let's have 0 as a convention. So if I say int n and then I say equals 0 by default, don't leave any variable declared without initialization. Well, a pointer is also a variable. This is what we said last time. But if we initialize the pointer to a value 0, in fact, we are giving it a specific address, right? 0 address. This shouldn't be the case because usually pointers later on are going to point to something more concrete, which is the address of a variable or an array, for example. But also, if you assign an address, a specific address, to a pointer that unintentionally don't want to do that, to do this, you can, without intention, modify this memory content. So usually people, to safeguard against modifying memory content, what they do is when they declare a pointer, they initialize it to null. What null means? It means it's not pointing to anything. So it's a pointer that is not currently pointing to any variable or anything, right? Why that's good? Because later on, when you really want to test, for example, you want to use dereferencing, you can have, for example, an if condition saying if the pointer is not null, then do something. If it's null, then you know it's not assigned. So people use this null as an indication that this pointer has not been initialized later on. And it has more uses that will come later on when we talk about malloc or dynamic memory allocation. Because if you try to allocate a memory, usually this memory returns to you the address of the allocated region in a form of a pointer. But what if the memory fails to find enough memory for you? Assume, for example, I'm asking for 4 megabytes of memory, but my memory currently does not have that. What is going to happen? We will see that malloc returns to you a null, which means I wasn't able to allocate this memory for you. So by doing a checking of the returned pointer value, if it's a null or not, you know whether the memory has successfully allocated your space or not. Good? Please. That's an excellent question. So, and this question is very, very important to differentiate between two main things that we said last time, but they will come with the experience. The more we deal with pointers, the more we understand them. Pointer is special in two things. It's a variable on its own, but it's holding an address to something else, right? So which means, in fact, there are two memory locations we are talking about. We're talking about the pointer address itself, or the pointer variable. Here it's b pointer. And then b pointer is pointing somewhere in the memory. And this somewhere, this arrow here, is in fact the address, this address, 0xf, for example, that's the value written here, correct? So if I have this as null, in fact, what is happening in memory is, again, this is b pointer is a normal variable. It's assigned a null, so I have a null here. What null means is that this arrow is not going anywhere in the memory, right? It's just angling point, like it's not pointing somewhere, right? So there is still allocation in the memory for the pointer variable, because even if I didn't initialize, by doing this, you are really declaring a variable, a pointer type of int, which means it's 64 bits, so it's 8 bytes, and this is the location of that pointer. Everything I have afterwards is what is the value that is stored in this place, right? Which happens for pointers to be another address, right? So if it's null, yeah, the pointer is in the memory, but it's not pointing somewhere. Good. Is there any other question? Okay, great. So I'm initializing a pointer to null, which means, well, say for right now, we said this should be your programming practice. Any pointer when defined, either assign it to something you know, which is the address of n, as we have done on Wednesday, or assign it to null and then later on overwrite it. And then I'm initializing two other variables, a and b. Well, one question to you, which might be something that can be a form of a multiple choice question. In line 2, what would be the end value of a and what is the end value of b after I execute line 2? Yeah. Exactly, thank you. So put in mind that when we define multiple variables with the same, or declare them in the same line, I can assign those variables different values. A is not initialized with anything, which means it's garbage in the memory, right? Not initialized. And B gets the value of 25. Don't get confused and say that 25 applies to A and B, right? Good. And then in line, yeah, there was a question. Good. So then in line 3, I'm assigning B pointer to the address of B. So I am making B itself, taking its address and put it in the B pointer location. And then in line 4, so let's really visualize this one by one. So initially, B pointer is null. This is basically, well, nothing, right? Just here, where this is written 0, but it's in fact doesn't mean address 0. It means, well, the special representation of a null, right? Because 0 might be a valid address. And then initially A is not declared. Sorry, it's declared but not initialized. That's the AND here. We don't know its value. It can be any garbage. And then B has the value of 25. Great. This is after the first 2 lines. And then in line 3, what I'm doing is I'm taking the address of B and putting it in B pointer. So if I look, what is the address of B here in the memory? It's this value, right? This is the value, and this is the address that is pointing into it. So I'm taking this and put it in B pointer. Does make sense? So B pointer now holds the address of variable B. This is after line 3. Everything else is the same. And then in line 4, what I'm doing is applying what we have learned in the previous 2 slides. I have a dereferencing operator, which means read the value of P pointer. What is the value of P pointer? Just variable B, right? This is like similar to what we said in the previous slide. This is completely equivalent to B, right? So now this is as if we are saying A equal B. So what happens after line 4 is that A also gets the value of 25. Make sense? And then in line 5, what I'm doing is I'm overwriting the value of P pointer to 0. Again, what is the value of P pointer or the dereferencing of P pointer? It's the variable B. So I'm overwriting it to 0, so B gets the value of 0. Does A change at all after line 5? No, there is no relationship between the variable B pointer and A, right? Line 4 is only taking a value, put it in the variable. So it's A equal B. If you modify B afterwards, A remains the same. Makes sense? Something confusing? So as I said on Wednesday, ask questions throughout the way, because we have to take this thing step by step. And you have to make sure that every single piece of information we convey, you get it, you consume it correctly, because we build on top of it later on, right? This is how we navigate that topic, please.
So on line 4 is didn't have the asterisk, they would just take the.
That's a good question. And if we try this on line GDB or your own compiler, and you say A equal B pointer, you will get what? Okay, maybe I should ask. What do you expect? What's going to happen? Yeah, it's not defined. Yeah, so these are 2 different types that you cannot cast to, right? So you cannot assign a pointer to a normal variable. So in that case, you will get a compilation error, because A is of type int, B pointer is a pointer. You cannot assign a pointer to an int. Make sense? Yeah. Yeah, so, well, I guess you wanted to say if I want to do something like this. Correct? So in that case, you can still do it, because this is equivalent to B equal A. Even if A holds any garbage value from the memory, just B is going to be overwritten with this value. Oh, without the asterisk, that's also not possible, right? Put in mind that I see what you mean. So let's look into line 3. So what if your question is equivalent to say, what if I want to do this? Yeah, or B, or basically take its address. So I can do something like this, B pointer equal and A. Put in mind that the pointer holds only addresses, right? So you cannot put an int into a pointer. What you can do is you can take the address of that int and put it into the pointer. Okay. Yeah. Okay, so this question I'm going to break into 2 different questions. Yeah, I'm going to break into 2 different questions. The first one is A remains int. It's not a pointer. Then definitely the int cannot hold an address. So the direct answer is correct. In this following example, A cannot hold the address of P, because I cannot assign an address to an int. But maybe what is in your mind but not very clear is, can I have another pointer that can also hold the address of P or the address of A? So you can have multiple pointers pointing to the same variable. You can have even the B pointer here pointing to A instead of A, because you can modify them, right? And we'll come into this later on. But now we want to make the point that ints cannot be assigned to pointers, pointers cannot be assigned to ints. Only pointers hold addresses, ints hold int values. Yeah.
Specialized a like but as int asterisk.
Yeah, that's also a good question that goes back to one of our few very first lectures in C. So in Python, I can, well, in fact, because this is an interpreted language, you can change the type of the variable along the program. In C, that's not possible. You cannot have the same variable as an int at the beginning and then later on as a pointer, right? So we cannot change types on the fly. Good. So it's a strict programming language where I have A as an int throughout the program, it must remain A through the visibility. If you have a local scope, another function that doesn't see A, then I can redefine what I want to do. Yeah. Exactly. Yeah. For this snippet code, that's correct. Yeah. Yeah. So this kind of covers what we discussed in previous slide. Is that I can have the address, so we know this. We can also have a null pointer, which is pointing to nothing, and then also I can assign a pointer to a pointer, right, of the same type. For example, here I start by initializing two pointer variables, n pointer 1 and n pointer 2, and then a normal int variable. And then this is basically what happens when you declare this line in the memory. You have n pointer 1 as a variable, n pointer 2 as a variable, and then the n integer itself. We use this dot to basically reflect a pointer because later on we'll add the arrow, right? And then if I have a line of code that is saying n pointer 1 equal to the address of n, what do you expect to happen visually? Is that n pointer 1 is going to point to n right now, which means reads its address. This was going to happen. And then if I add another line saying n pointer 2 equal n pointer 1, well, simply another arrow from n pointer 2. So they're pointing to the same place. Make sense? This implies a very important thing. If I wrote something like n pointer 1 equal 3, and then later on, I try to print the value of n pointer 2. What do you expect to find? 3 as well. Because from this visual effect, both are pointing to the same place. So if I wrote this thing, n here will be 3. So if you try to print n, it will be 3. If you try to print asterisk n pointer 1 is going to be 3. Asterisk pointer 2 is going to be 3. Yeah, sorry. There was a question here and then I take yours. Yeah. To the same place, exactly, because you are not modifying the address, but rather the value that it's pointing to. Yeah. That's an excellent question. Yes. In fact, very, very practical reason when it comes to data structures, because think of, well, without going into deep details, and we'll cover them towards the end of the course, but assume you have a chain of links. And those links are dynamic, so it's not like the array. By the index, you can access them. In fact, you need the address of every single one. That's why they point to each other. Assume you want to navigate this linked list or chain, but you only have the address of the first element. So what you want to do is you don't want to modify the head. We usually call this the head. You keep the head as is, because if you lose the head, you lose the linked list. But if you want to, well, navigate it, right, or search it, you assign another pointer to that head and move that pointer. So now 2 pointers are pointing to the same place. One of them is virtually static, which is the head you don't want to modify. The other one is the one that you can modify easily, right? So say like the head is n pointer 2 such that it goes later on can be modified without losing access to n. That's correct. Yeah. Great. So this is basically the example we have here. And as I said, if you modify n pointer 2 to some value, 76, for example, n will get the value of 76, which means if you try to print n pointer 1 or 2 or n, you get 76. And then, again, once you understand the rule that the asterisk or the dereferencing of a pointer is equivalent to the variable itself, so if you have a hard time seeing this, just take this one, replace it with n. What is going to happen if I have plus plus n? What do you think? 76 will be 77, right? So that's completely equivalent to just do that, right? And also completely equivalent to say plus plus asterisk n pointer 2 as well. Any question? Great. We already had this. This is an example of a double. Point to nothing. Yeah, okay. A null pointer cannot be dereferenced. Yeah, what do we mean by a null pointer cannot be dereferenced? Assume you have these two lines here, and then I want to say I have another double n, and then I say n equal b2. Well, this is not a valid statement. Why? Because there is no value. This is what, well, this is why I call the asterisk operator dereferencing operator. Because if you think about the pointer as a reference, by putting the asterisk, you get the value of the reference, which is dereferencing, right? This is what really it means. So now what is the problem with this line? If I try to dereference P2, which means it's the address, go to that memory location, obtain the value, well, there is no address, right? It's not pointing to anything, right? So why this statement is problematic, right? Because it cannot really point to anything. Yeah. This might be a charger problem. Yes. Yeah, well, let me try to remember. Is this like a runtime issue or a syntax problem? I guess the compiler will be able to capture it statically, if I'm not mistaken. If I might be wrong, I need to try it. Yeah, but what I'm sure of is, in fact, you must get a. Let me see if the power will work from here. You must get a compiler error, so it's not to not work, because definitely this statement cannot be executed. Yeah. Yeah, here comes the interesting part. Pointers are great into passing things to functions, right? If you want them to modify it. So you remember the limitation of a function in C that you cannot return more than one value. Then you pass the input, like whatever you want to virtually have as an output, as an input parameter, but pass its address with the AND operator, right? Now we understand that this AND operator of the variable is nothing other than, in fact, a pointer to that variable, right? This is why pointers to functions is, in fact, very key in C programming. And this is what we call is passed by reference, which means you pass the reference to this variable, which is the pointer to the variable. So let's have an example, which is something we wanted to write for a very long time, right? Having a swap function, right? Because swap is a very common utility function that you want to change two variables simultaneously. I'm talking about if you want to swap two variables only. In that case, you want these two variables to be modified. I cannot return both, which means I need to pass both as an input parameter, but pass them with the address. We have been using such functions like scanf mainly, but we have never wrote one, right? We have never wrote a function that takes a variable by reference or by pointer and then modify it. So I guess the time has come such that we should be able to do this. So in the main, so every function has three things, as we discussed before. Well, the calling of the function, right? And the prototype of the function and the body of the function or the implementation or the definition. So here, assuming the main, I have two normal variables, a and b, both are ints, 100 and 200, and then I'm calling a function called swap. From this interface, we know that swap should in fact swap a and b. So after calling swap, a should be 200 and b should be 100. And then this is the prototype of the function itself. So I have void, which I'm not returning anything. But now comes the interesting part, is how do I really pass this thing by the address? I must take this, consume this in the function as a pointer, right? Now we have learned that, right? So here I'm defining a pointer of type int because I'm expecting an int, another pointer of type int. Great. And once I call this function, I know the address of A will be consumed by X pointer, the address of B will be consumed by Y pointer. So by just calling this function, you have these two pointers in the local scope of that function. X pointer is pointing to A, Y pointer is pointing to B. Are we good so far? Yeah, in fact, they are the complete opposite of each other, and that's important to understand. So the AND gives you the address, but the asterisk. Oh yeah, I see where the confusion comes from. Sorry. So asterisk is in fact it has been used now in two different places, correct? in the dereferencing, that's one thing, but we also use it to define a pointer, right? So in this pointer definition, it's in fact doing nothing other than declaring a type, which is saying X pointer is not int, but it's a pointer to an int, right? But the main difference in the using, aside from declaration of pointers, is that the asterisk gives you the value that the pointer is pointing to. So in other words, in the asterisk, I'm going from here to here, right? I'm using asterisk X pointer to get 100, but so this is the asterisk direction. But the AND is getting you from here to here. You go from A to X pointer. Yeah. That's a good question. So, and we will come into this. So if you do something like this, so you can try, you guys are good. So you can try these things in your compiler. If you do this, in fact, you cancel each other, because what you say is, I have an X point. This is completely equivalent to X pointer, right? Because what do you do is in the first dereferencing, you go to N, for example, or A in our example here, and then you take the address of A, so it gets you back. This is why I said it's two-direction thing. So using the dereferencing gets you in that direction, and then you come back with the AND. It's just you are still in the X pointer place, right? So it's like saying the address of the value of X pointer, which is effectively X pointer. Here, like this thing? Yeah, the address of A, which is effectively X pointer, right? Because we know X pointer is the address of A, right? This is why I said they cancel each other, basically. Good. We already explained all of that. So let's see how the code really works. So I want to swap these two variables, right? So what should happen is I should have a temp variable. It's of type int. But then I don't want to show line 2. What do you expect line 2 to be? How can we write it? By what we have discussed so far, we should be able to write it. Yeah. Exactly, thank you. So here inside this function, I don't have A or B, but I rather have the pointers to them so I can get their value. Sometimes I see a lot the mistake of forgetting this dereferencing. That's a compilation error again, right? Temp is an int, X pointer is a pointer. You need the value of this int pointer, which is an int, right? Makes sense? So by putting the value of X pointer to temp, it's basically A value is in temp, and then I overwrite X pointer and Y pointer. Just let's take them line by line. So here I have this temp variable. I take temp is equal to Y pointer dereference. It's the same as your friend said. I either start by Y or X. It doesn't really matter because I'm swapping. And then in the line 2, what's going to happen is initially temp wasn't initialized at all, right? So it's just garbage. In line 2, I'm assigning Y pointer value to temp. What is the Y pointer value? Y pointer is pointing to B, so it's 200. So in line 2, temp gets the value of 200. And then in line 3, Y pointer value, which is effectively B, is getting the value of X pointer value, which is A. So it's B equal A in that case. So if you see in line 3, B get overwritten by the value of A. And then in the last line, A is being overwritten. Makes sense? First question, do you see how in fact, we cannot do this without pointers? Makes sense? Because without pointers, the best you can do is only pass A and B as values to the function, as we discussed before in function calls, right? So there is no way to modify A and B unless you pass their addresses and modify their memory locations directly through pointers. Questions? Please ask, because if you understand this slide, I mean, a lot of things coming afterwards are much easier, yeah. You want to do something like this? Yeah. Sure. So let me ask you that. So first of all, what is the type of temp? Int. What is the type of this thing? It's a pointer. So you cannot assign a pointer to it, right? Good. So all what we said is correct about this, but the outcome is infinite. Exactly. Yeah. That's also a good, yeah, well, a generally good question, and then I'll buy to this function. If the pointer is dynamically modified, as we said before, you can in fact modify the value of the pointer, right? Itself. Well, like, let's look into this example here. This is what we have.
I guess we can't do it because the best for variable.
Well, I see. Okay, so but first of all, like let me break that question into two parts. Generally, can we modify pointers like the addresses that they are holding? Yes, that's an example, right? But how can this help us here? Let's see. This is also a common thing that I see. If you do something like this, so your friend's saying, I want to modify which is pointing to which. So you want to modify, well, once you receive X pointer and Y pointer, you want X pointer to point to B and Y pointer to point to A, correct? Good. If you do this, does this impact at all? What is the value of A or B? Exactly. So you switch the pointers, it's functionally correct, but it never gives you the swap because at the end you want to swap the values. This is why here we are all operating on the dereferencing operator, not on the addresses themselves, right? So if you write something int pointer temp, and this is also, in fact, I had this question in one of the midterms before, and I saw this answer a lot. So you define a temp pointer, and then you say temp equal Y pointer, and you continue as you suggested, right? You swap the pointers. Good. You have done something, but no change at all in the main, right? A remains 100 and B remains 200.
Is it because like the pointer value is actually passed
by value? Exactly. Yeah. The pointer values themselves are passed by value, and we'll come into this when we talk about double pointers. Yeah. Good. Okay, great. So we're doing great so far. How much time do we have left? Okay. So assume also I want to, well, we have seen the swapping. Assume I want to get the sum and the def. Swapping is changing the input parameters themselves, but you can extend the concept by saying any function that want to return more than one value, I can use the pointers for this. For example, assume you want to write a function that does not only return the sum of two variables, but also their difference, right? So now I want to return two things. And these two things are different from my input parameters, right? So how you think SUMDIF should be prototyped? How many input parameters I should receive here? 4, exactly, yeah. Great, thank you. So we should have 4, the original input parameters that in fact I should use to sum and do the subtraction, but then the sum itself and the subtraction should also be passed to be overwritten. So it should be passed by reference, right? So that means they should be passed as pointers. So in that case, if I want to use this function, I will call it by passing x, y. You observe here that x and y are just normal values, right? Because I don't want to modify them. But sum and def, this is what I'm expecting to return or modify within my SUMDIF function. I should pass their addresses. And then going to the actual prototype of the function, this AND thing, we know right now that it in fact should be received as a pointer to an int, right? And the same thing for the difference. Okay, so yeah, this slide is trying to basically simplify a little bit the thinking about the sum and the def. Is that within a function that is receiving a pointer, if you only operate on the values that this pointer are pointing to, most of the time don't think about the pointer itself, but rather think about the variable, right? In fact, you don't care about the address itself of the pointer, right? This will simplify the confusion that also you had here, is that if I'm only concerned about the difference of x and y or the summation or swapping the variables, all the time I should be operating on dereferencing with pointers, not the pointers themselves, right? So if you look into this function, well, it's just composed of only 2 lines without even a return. The asterisk of sum pointer, which is the value that this is pointing to, which is effectively the sum, is the a plus b, and then the difference is a minus b, right? I could have defined another variable called int sum and int diff inside my function, and then do the addition subtraction, and then assign sum to my sum pointers, but it's not really needed, right? Is that clear? Okay. So if we look into how these things again work, just to visualize them in our minds, within the main, I have the sum and diff and the x and y. In my sum diff function stack, or the memory visualization of it. So I have 4 variables, a and b, and sum pointer and diff pointer. I know the sum pointer is pointing to sum, diff pointer is pointing to diff. A will get the value of 100, right? So in fact, if we want to completely visualize this, I must have x and y here, and this is 100, and this is 200. And this is a very important clarification, or showing the difference between passing by value and passing by reference. In the x, y, and a, b case, I copied the value from x to a, and copied the value from y to b. But if a or b are modified within the function, so if I came here and modified, said a equal 300, does this change anything? No, x is not going to be modified. And the reason is these are 2 different memory locations. There is no link between them. Only when I start, I copy the values from here to there. Good. So a gets 100 and b gets 200, and x and y remains the same. And then sum pointer gets the address of sum, diff pointer gets the address of diff. And then by doing the first line, the value that sum pointer is pointing to, which is sum, gets the summation, which is 300, and then the diff gets -100. Clear enough? Okay. Are we good? So I'm not done yet. So I want to leverage the remaining 5 minutes because I want to go quick to catch up with the lab. So let's okay. So this is a topic that we discussed on Wednesday as well, when we discussed the relationship between pointers and arrays. And we said the way really the hardware knows how to index an array is doing pointer arithmetic, right? Remember we said you just take the address name as a pointer, you add whatever value that is your index and multiply by the width of your data entry, right? So now we discuss this a little bit more. This is usually in programming, this is referred to as pointer arithmetic. You can add some value to the pointer or subtract some value from it. And the remaining result is in fact a pointer as well. So let's have some examples. Assume you define, let me see if I have a visualization. If I don't, I should. Okay. So what I want to do here is I'm defining an array that has 10 elements. It's called A. Some values here. And then I'm defining a pointer of double. And then later on, I'm assigning a pointer to the 4th entry of the array. So where is the 4th entry? That's 0, 1, 2, 3, 4. So what I'm doing in this 3rd line is making a pointer point here to the 4th element, which has the value of 4. Is that correct? Yeah. And then I'm doing some pointer arithmetic, a pointer minus 2. So what does this do? What is the new pointer that I get as a result here? Yeah. What do you think? Where a pointer should point? Any idea? Yeah. 3rd element, you mean 2, right? Like basically, yeah, 3rd element is element 2. That's correct. So it's basically is a pointer of type double because that's the result. And then it also holds the value of a. The way you read this is a pointer is pointing to a4. You subtract 2 from the index, so you go by 2. One question could be, well, how does the hardware know? If we think carefully, a double might be 8 bytes, correct? So when I say a pointer minus 2, in fact, I'm jumping how many bytes back? 16 bytes, but I only showed 2. So how does the hardware know that in fact these 2 should be multiplied by 8? from the type of the pointer itself, right? This is the key in pointer arithmetic, is that the hardware, when it executes this line, it has a pointer. What is the type of a pointer? It's a double, which means it's pointing to a location that has 8 bytes, for example. Each time you do a pointer arithmetic, multiply the offset by that size. If a pointer was instead of type int, what's going to happen? It will jump only 4 locations, or the corresponding number of locations, right? Does this make sense? So it's pointing to A2, great. What about doing something like this? If we know a pointer minus 2 is in fact just a pointer on its own, I can dereference it. So if I'm doing a line like that, how to decompose it? First of all, look into the pointer arithmetic. A pointer minus 2, the way I can handle it is to say a pointer is equal to A4 address, subtracting 2, so this should be 2. This is going to be A2. And then that's the address of A2. And then doing the dereferencing means take the value of A2 itself and then assign 10 to this. So this line is completely equivalent to say A2 equals 10. So what is going to happen is the hardware will come here and override the 2 with 10. Becoming complicated? Yeah. Yeah, how many bytes are going back? So it depends on the type of the pointer itself. So this is a pointer of a double. Assuming that a double, let's say 64-bit, right? Because it's a machine dependent, let's say it's 64-bit, which means 8 bytes, right? So if this 8 bytes and you are jumping back 2 locations, so you're jumping an 8 and then another 8. So it's going to jump 16 bytes back, right? But effectively in the array, it's only 2 locations because every single one here is 8 bytes. Sense? So here A2 gets the value of 10. Good. Well, complicate it a little bit more. Yeah, please. Yeah, the array name points to the first M. That's correct. Yeah, you can dereference it. The only thing you cannot do for the pointer of the array name is to modify it, but you can dereference it. And we will have examples for this later on. Yeah, please. Sorry, can you be quiet a little bit because I don't hear the question. Yeah. Correct. That's correct. That's correct. So because again, it's not aware. So the pointer arithmetic, the hardware is not aware of what is this pointer is pointing to in reality in the memory. It only knows that it has the type of double, and then it will be jumping accordingly. That's correct. Yeah. Okay. So given that you guys are starting getting a little bit loud, I will say let's stop here, and then we continue next week. Okay. So I will post. So one very important thing. Sorry, 1 minute. So to be able to start with the lab 3, so what I'm going to do is I will post this presentation, right? In the Tuesday tutorial, they're going to cover, you need one other concept that is very important, which is structure. But by Tuesday, I might cover it in the Tuesday lecture or Wednesday lecture. So, but what I'm going to do is they will cover it in the tutorial quickly. I will post the video from previous years as well. If someone wants to have a head start on the lab, they can also do that. But you can answer at least the questions in the lab related to pointers only, right? And then when we come to structures, you can continue with them. Good. And I would assume you will be busy with the midterm anyway. So yeah, good luck.